If you were to ask people what the world's most precious resource is, the answer you get might be different depending on who you ask and where they're from. If you ask a farmer in a semi-arid desert, your answer might be pretty, well, transparent. Human civilization, and in fact all life on Earth, relies on fresh water. Nowhere in Western Canada is that more evident than in Lethbridge, Alberta. Bisected by the Oldman River and surrounded by farmland, Lethbridge owes its past and future to the meandering channel at the center of it all. Water is one of the most unique substances on Earth, and as such is one of the most difficult to understand. It can exist in 3 states simultaneously: a liquid, a solid, and a gas. It is moved by gravity, by the wind, and by our nearest planetary neighbor, the Moon. Although 70% of the world is covered in it, less than 1% exists as fresh water.
Given its significance and relative scarcity, fresh water is a topic of intense research around the world. At the University of Lethbridge, scientists like Dr. Chris Hopkinson work to understand the mechanisms at play in the water cycle. Under conditions of climate change and a growing population, there is expected to be increased pressure on the resource going forward. With a team of graduate students, Hopkinson studies the interplay of land use, land cover, and meteorology in southern Alberta's headwaters. The headwaters are the origin of the Oldman River and exist in a narrow band of mountains along the eastern slope of the Rockies. Using the latest in satellite, ground-based, and airborne technology, Hopkinson and his students are collecting data in the hopes of creating a hydrologic model. A hydrologic model is a digital representation of the water cycle. It considers precipitation, evaporation, groundwater, and stream flow. It also accounts for topographic elements like elevation, slope, and aspect. It's an incredibly challenging subject to examine, said Hopkinson, because there are so many variables in the equation. Everything works together like the gears in an enormous clock, moving in time with the seasons. By understanding how the system has worked over time, scientists can more accurately predict what may happen in the future.
The cool thing about hydrology, I think, is that it's such a diverse subject. Fundamentally, it deals with water, right? And water's properties in the landscape, as opposed to in the ocean, of course. Lots of water out there, but hydrology doesn't tend to focus on the oceans. It's more water on the landscape and in the atmosphere, dealing with the water cycle and how water moves through the landscape. So it's very multifaceted, very complex. We're mostly water. Water's all around us. Without water, we can't live. It's probably, well, it's like oxygen. It's fundamentally important to us as human beings. Without water, we don't do so well, and if we've got too much water around us, we can also not do so well. So in hydrology, we're trying to understand that balance, you know, and as humans, it's absolutely critical that we understand it. It controls where we live, how we can move through the landscape, and how we can interact with the landscapes. I think as humans, we have always worried about water and the availability of water. Our settlements historically have very often been adjacent to rivers for the mere fact that we need to use that water to drink, to supply our crops, to navigate, to move around. So it's always been there. I think maybe as humans we're, as time goes on, we're more critically aware of the nuances of our relationship with water and the hydrological cycle, but maybe more fundamentally how our actions affect the availability of water and the way it cycles through the landscape.
Students like Kelsey Cartwright are working with Hopkinson on various aspects of the water balance equation. Cartwright is using airborne LiDAR technology to measure the snowpack in order to estimate the amount of water stored in frozen alpine regions.
My research is really interdisciplinary in that it combines remote sensing, GIS, and hydrology, and some statistics, and wraps it up in one nice package that'll help to improve water supply forecasts. Airborne LiDAR is a sensor that you put in an airplane or a helicopter, and it shoots photons or little bits of energy at the ground and measures the distance it takes for each little piece of energy to bounce off of a target, whether it's a tree or the ground, and the output is a map that'll tell you the height above ground that every little XY point is. So you fly twice, and then you take the data from the winter and you subtract the data from the summer, and the only difference between those two data sets is the change in height of the ground, which is the snowpack. It's really important to study the snowpack in southern Alberta because it's our main source of water, and somewhere like Alberta we not only have a really robust agricultural sector that requires irrigation, but we also have agreements with Saskatchewan to pass on a certain amount of our water to them for their purposes. My favorite example of our threat to water resources in southern Alberta was Put Well by Corb Lund, and he sings in the song, "The truth comes out, the winters got warm, not as much snow." There's our problem right there.
Celeste Barnes is looking at global circulation patterns, meteorology, and channel dynamics to predict extreme events like drought or flood.
One of the reasons why I enjoy working with Dr. Hopkinson is because he allows the student to come up with their own ideas and run with them. Dr. Hopkinson has actually worked in industry as well as in academia. Like, he brings that expertise to the university, and that's the type of expertise that he's trying to disseminate to his students.
The future of communities around the world is hinged on the thoughtful management of our finite water resource. Changes in the environment, coupled with increasing demands for food and drinking water, make the science of hydrology ever more critical. Thanks to the research efforts of scientists like Hopkinson and his team, perhaps we can find a way to live more harmoniously within our means.